Hi, I'm Zac Shenker from Fastly, and I'm going to talk today about what's new in HLS, specifically around the Content Steering and Interstitial specs. So first today we're going to look at Content Steering and Multi-CDN switching as it exists in HLS today. We're then going to take a look at the new Content Steering spec and what that provides. We'll then shift over to look at server-side add insertion and content stitching today. We'll then look at the new interstitial spec and how you can use that. Then we'll talk a little bit about the HLS community, how you can stay up to date with changes in the HLS spec and what might be coming. Finally, we'll talk about device support for these new specifications and how you can start to implement and use them. So let's jump into multi-CDN and content steering. So today, this isn't really a native part of the HLS spec or ecosystem, but there's a number of different approaches that have been developed to allow for multi-CDN switching with HLS streams. The first is a DNS-based approach. In this approach, a DNS system is used to give different DNS answers to different clients so that different clients will utilize different CDNs. This is very easy to integrate and support across a very wide range of client platforms. However, DNS TTLs are not always well respected across different ISP resolvers or different clients, so this may mean that you don't have real fine-grained control over when different clients will switch between different CDNs. Next, there's manifest-based switching. And here, there's two primary approaches that can be seen in the wild. The first is a redundant streams-based approach, and we'll talk a little bit about this later, as some of this also influenced the content steering spec. In redundant streams, the same renditions are advertised multiple times, but coming from different CDNs. So it's then up to the client if it incurs any errors or problems as to which CDN it should use. The challenge here is you can't always heavily influence or be sure of how different clients are going to prioritize or use the order of these streams. Next, there's a per segment-based switching approach, and this primarily applies to live streams, where as new segments are added, you can rewrite the segment URL to select the CDN that should be used. This approach doesn't really work on VOD streams, as you have to write all the segment URLs at the beginning of the stream. Next, there's client-based switching. This offers a lot of fine-grained control, but it can be really difficult to integrate on all platforms and to provide a consistent experience across all of your devices. So let's have a look at this new content steering spec. So, the Content Steering spec provides a method for clients to frequently fetch and update CDN selection from a remote server. We'll focus today on the latest version of the spec, 1.2b1. This spec was designed to be backwards compatible, so clients that don't know about content steering are still able to use these manifests and these streams. Today in the spec, all CDNs must be specified upfront in the master manifest, but in the future, Apple may allow additional CDNs to be added via the steering server's response. So let's talk about how you indicate and signal that content steering should be used. There's a new tag that's been added to the HLS spec here, EXT-X Content Steering. And to this tag, there's two attributes that can be provided. The first is the server URI, and this is an absolute or relative URL pointing to the steering server that the client should make requests to. The second is a pathway ID, and this is the pathway ID or name of the default pathway or default CDN that should be used. The spec here is designed so that the client can still start playback using that default pathway before it's got a response from the steering server. So this means that the request to the steering server doesn't block the start of video playback. So then there's additional query parameters that the client can also add to the steering server request. You can see here that all of these query parameters use the _HLS_ prefix that was first introduced with the HLS spec. Here, there's two query parameters. The first is HLS pathway, and this is the ID or the name of the current pathway or CDN that the client is using. The other query parameter here is the throughput, and this is the latest bandwidth estimation or throughput that the client has seen. These values could be used for analytics and understanding how clients are performing with different CDNs, or you could use and factor these in to decisions that the steering server makes. So let's now talk about the steering server. So the steering server returns a steering manifest. This manifest is a JSON response with just a couple of fields. The first is version. Version in the current spec will always be 1, and this will be updated as there's any changes to the steering manifest spec. Next, there's TTL. This indicates how long the client should wait until it next makes a request to the steering server. This can be modified in each response from the steering server, so you may want to change this if you need to impact load on your steering server. Next, there's the reload URI, and this is the URL that the client should use on the next request that it needs to make to the steering server. In some cases, this may be the same, and this is also an optional field, so you could leave it out on further responses. You could also use this to add additional metadata, like if you wanted to generate a session ID on the first request to the steering server, you could then update the reload URI so that the client adds those values on the next request that it makes to the steering server. And then finally, and most important, is the pathway priority. And this is an array, an ordered list of the CDNs that should be used in the preferred priority order. So let's take a quick look here at a sample of a steering manifest. So in this case, we have a manifest with a TTL of 300 seconds. We're indicating the reload URI that should be used on the next request. And then we can see that we have two CDNs in the list here of priorities, CDN A and CDN B, and they'll be used in that order. So let's now talk about some changes to the EXT-X-STREAM-INF and I-FRAME-STREAM-INF tags. You'll see here there's a new parameter, the pathway ID, that can now be added as an optional parameter. This indicates the pathway that a particular rendition belongs to. This uses a similar approach to redundant streams with duplicated tags for each rendition for each CDN. Thanks to Phil Clough at Mux for coming up with some of the ideas here around repurposing redundant streams into this approach. The rendition manifest URIs here can be absolute or relative, but it's likely that you'll need your non-default CDNs to be absolute URLs so that the client makes the correct request for any of the manifests or segments. This implementation also allows the tokens to be unique for each CDN for each rendition. But the master manifest token would need to be valid for whichever CDN the request for those master manifests actually lands on. So let's have a look at this master manifest example here. So at the top here, you can see that we now have this EXT-X content steering tag as we've described before. You'll now see that there's two different renditions here, a low and a high quality, but they're now listed 4 times. So you'll see that the first two indicate a pathway ID of CDN A, and then the second two here indicate a pathway ID with CDN B. So that was the content steering spec. Let's now talk about SSAI and content stitching. So SSAI in HLS Today also was never really a native part of the spec, but has been implemented relying heavily on the EXT-X discontinuity tag. This tag indicates to the player that there's some upcoming changes in the next segment. This is used as part of rendition manifests, and often this causes players to reset decoders or potentially treat the next segment that's coming as something different from what it's seen before. This is a basic example of how you might use a discontinuity tag, where in this case we have two segments that are our pre-roll ad, and then we insert a discontinuity, and then we go to our main program content. There's a few challenges with this approach. Not all players handle discontinuity tags well or in a consistent way. In some cases, players still expect that the attributes of a particular rendition and segments in that rendition don't really change too much, and this often leads to the ad content needing to be encoded and prepared in a very similar way to your program content. By default, this also means that ads can only be placed at segment boundaries, unless you go through an approach known as preconditioning, and in this approach, you may split segments at the ad boundary at an iframe, or if you control the encoding, you may insert keyframes at the ad break boundaries to make sure that you can introduce ads exactly where you want them to go in the stream. This requires extra processing and extra work as part of your media processing pipeline. For VOD, all the ad segments must be listed when the rendition manifests are generated. This means if you have a lot of ads in your content, this can really slow down startup time for your streams. Finally, some client code and SDKs may be needed for things like ad impressions or for UI behavior like blocking out ad controls while you're in an ad break. So let's now talk about the Interstitial Spec and what this provides. The Interstitial Spec aims to make it easier to deploy ad-supported content in HLS. There's a server and a client implementation of this. This spec no longer uses or relies on discontinuity tags and is now a native part of HLS. This spec enables late binding and rebinding of individual ads and ad pods, which can be really useful for VOD use cases or in live streams where there's changing ad conditions and you need to move around where ads exist within the stream. This spec also natively supports navigation restrictions, including on AirPlay, so you're able to block out controls or disable seeking while you're in an ad break. This spec, compared to content steering, has more limited backwards compatibility. So clients that are provided with these manifests need to know about how to use interstitials. Today, we're just going to focus on the server-directed use case and primarily on VOD. So, how do we signal interstitials? So, the interstitials now use the EXT-X date range tags and rely on program date time being in the stream. We use the class attribute of the date range tag set to this value of com.apple.hls.interstitial to indicate that we have an interstitial that we want to signal. In this tag, in this date range tag, we can now specify assets that should be played as part of this interstitial in two ways. First is the X asset URI. This is a single URI to an HLS stream, master or rendition manifest, that indicates a single ad to play. The other option here is to use the X asset list attribute, and this is a JSON object that specifies multiple interstitials and the order that each of those interstitial URIs should be played in. Next, there's a resume offset. This can be used in a few different ways depending on what behavior you're looking for after your interstitial is played. With a value of 0, the resume offset will be used for VOD. Next, there's the XResume offset. This can be used to indicate where the player should resume playback of your program content after the interstitials have been played. For VOD, this will generally be 0, which will mean that the player will resume playback at the point that it stopped before it went into the interstitial. When not specified, the player should resume playback after the duration that it's been in the ad break for. This generally would be used for a live stream where you want it to skip over the period that you were out in the ad break, as generally you just have slate that might be in the program stream during that time. You can then also use the XPlayoutLimit attribute to specify the maximum time that the player should be within the interstitial. So this can be used to make sure that an ad break is no longer than a specific time. This could be really useful if you control the rendition manifests, but you're relying on an external provider to actually generate the HLS manifests that are played for the interstitials. Next, there's the XSnap tag, and this specifies whether the player should seek to segment boundaries as it goes out or in of interstitials. There are then additional options and additional attributes that can be used to specify how seeking behavior should be handled during ad breaks. So let's have a look at an example of how interstitials can be used. So you'll see in this stream, it specifies a program date time at 40 seconds here. You'll see that we, in the main content, just have our segments listed. But then down the bottom, you'll now see that we have an EXT-X date range that has the class indicating that this is an interstitial. We're able to give an ID to this particular interstitial, and then we specify the start date, which is also in a program date time format here, of when the interstitial should start. We're then able to specify the duration of this break, and then we provide the URI to a single asset as with the asset URI attribute. Because this is a VOD use case, we specify a resume offset of 0. So in this case, we'll play 4 seconds of the first segment, and we'll then go into this ad break for 6 seconds, and then we'll resume. If we didn't have the snap attribute specified, which we do here, which will slightly change behavior and force it to work closer around the segment boundaries. So that was the interstitial spec. Let's now talk about the HLS community. The best place, if you're interested in following what's going on in the HLS community, is to join the IETF HLS interest mailing list. This frequently has announcements from Apple, including announcements of presentations and sessions on the content steering and interstitial specs. This is also one of the best places to see updates and changes that are being published to the specifications. This mailing list has also been used for industry conversation and discussion about what's new and what's happening in challenges that different companies may be having with HLS. One thing I want to point out as well is the content steering spec was also heavily influenced and directed by different companies and by the HLS community. So a number of companies came together and discussed the initial version of the content steering spec and then worked with the Streaming Video Alliance to submit feedback and recommendations back to Apple, and this was used to update and change the content steering spec into the version that I discussed today. Finally, let's talk about device support. So the content steering and interstitial specs are available as part of iOS and tvOS 15, which have just become available. During betas, these features are behind entitlement flags that have to be included in the app to enable them to be used. Outside of Apple devices, there hasn't been much broad indication of public support, but there are many commercial and open source players that are starting to look at how to implement both of these specs and looking at supporting these into next year. I've also started some work on trying to implement the Content Steering Spec as part of HLS.js. If anyone's interested in this work, please feel free to reach out. Would love your help and support here. Overall, the Content Steering Spec seems to have consensus that it will be fairly straightforward to implement, particularly in players that already support redundant streams. There may be more challenges with supporting interstitials, particularly on platforms where only a single player or decoder is available. Thanks for your time today.